Hi everyone, my name is Mobreem. I'm one of the product managers on the OpenShift team here. And today's talk, I will be talking about how we actually use operators in OpenShift 4 ourselves. So in OpenShift 4, we have three major work streams: the day two operations, the immutable infrastructure, and the operator framework. We bring these three classes of work together to kind of bring you an orchestrated platform that will be something similar to like EKS or AKS. But the nice thing about this is actually a hybrid cloud experience. You could run this managed Kubernetes experience locally on your on-prem or in any cloud provider, so you're not locked into any vendor. So let's kind of dive into a little bit about like the day two operations. This is all about automation, starting from automation from the installer. We have a new installer with a one-click. We could install a brand new cluster for you on AWS. It takes about 20 minutes. It'll go provision everything that you need, everything from your create the VPC to your EC2 nodes to load balancers. One click and you'll have that. Then the next big thing for our day two operation is our automation using operators. So we now have like a machine operator that will give you auto-scaling out of the box. You could go ahead and define different types of machine sets. So if you have a special class of worker nodes or routing nodes or monitoring nodes, you'll be able to go ahead and define those. And the API will, or the machine operator will go out and be able to configure those for you and or scale up and down your cluster as needed. The next big piece of work is the immutable infrastructure. This is the stuff we got from CoreOS. So we have a brand new operating system, Real CoreOS. It's designed to give you over-the-air updates, something that's very important for us. Because we're doing this immutable stack, we're actually discouraging people from like SSHing into nodes. What happens at that point is if you SSH into a node, we will taint it. It's all about trying to avoid getting snowflakes or configuration drift. We want the system to be very consistent, and we want you to manage all that configuration inside the cluster itself and have that propagated through our operators to all your different nodes. The third big piece of this is the operator framework. We have improved SDK and the testing tools, as Rob just showed you guys. But one of the big things here is we actually operator ties the Kube stack and the OpenShift stack, and we're really all in on the operator framework and pattern. Another cool thing we have is the Operator Hub, which will let you guys discover additional and optional Red Hat services that you could go ahead and bring down, and or ISV partners. They'll be able to provide their managed services as well through there. The last component on here that's important is OLM, and that's the Operator Lifecycle Manager, and that will allow you to go ahead and, for example, if you have your service there, you can now get over-the-air updates to your services as well. So we're really going for that managed Kubernetes experience, including all the additional services that go on top of that. And between all these three work streams is how we're going to get you there. Now I kind of want to talk about a little bit about the past, how we used to do things. Before, you had to go ahead, install your OS, you had to go configure it. You then installed OpenShift 3 on top of it. That's a lot of manual steps. There's room for configuration drift. That's how you get snowflakes. We realized quickly that we had to bring it together, and how important bringing everything from the OS to OpenShift together. This way you can roll everything out in a very consistent fashion. So you're not going to get your configuration drift. You're going to have a very stable and reliable system here. So I kind of want to talk about what immutable infrastructure is. It means it's not repeatable. It means it's now auditable. So now if you want to just scale up more nodes, it's a couple clicks in the system, and you can scale up 5 nodes very easily. The other nice thing is auditable. All that configuration for each of these nodes is actually stored within the system. So you have a very nice way of keeping track of how everything is set up, and it's all cluster aware. What immutable isn't. It's not static clusters, and it's not no config changes. In fact, it's a lot easier to scale up and down your cluster with this system. The machine operator will handle all that for you. The other nice thing is it doesn't mean no config changes. In fact, the system is aware of all the configuration changes, and if you want to go ahead and update a security setting on a type of node pools that you may have, the system will grab that and do a rolling config change to all those worker nodes or whatever type of node that you need to get updated. So another important thing here is think about, this isn't day 2 management. Think about this as day 365, right? Your admin's gone, a new person comes in. They don't have to worry about how am I going to spin up another 5 nodes. It's all within the system, and the system will do that for you. All right, so I want to introduce something new here. We have a couple of new cluster API objects. Think of this almost as like deployment, replica set, and pods, but now it's machine deployment, machine set, and machines. This is for you to define your different types of nodes that you may have. You may have a type called worker, you may have a type called monitoring, you may have a set of nodes that's for routing. We will manage that via the machine operator now, and that is all automated for you. I'm a UI guy, so I kind of want to give you guys a couple screenshots of what the new UI looks like for 4.0. As you notice, there's a new machine section on the left-hand side, and currently I'm showing you guys the list of machines. The nice thing here is you can see that there's 3 masters currently, and then there's 3 workers. You'll see what region they're in and the availability zone that they're in as well. Now here's a list of machine sets. The interesting takeaway here is you're not going to see any masters. We treat the masters as special, so you're not allowed to create a machine set for that because we don't want you to auto-scale up and down your master set. Another interesting thing here you'll see is some of the machines are set to 0, and that's because you put the desired state in this cluster as I wanted 3 workers. The machine operator then roll it out to the first available regions, availability zones, and put it out there for you automatically. All right, so here we got a possible cluster architecture. In the top left, you have the control plane. Those are M3 extra larges. Then you have some high CPU systems for your logging and monitoring. But then you'll notice that both workers and routing have M5 larges. Why are they separated out? Well, they could have different configurations, different security settings. For example, the routing is actually accessible by external traffic, so you may want to have additional security configurations set on it. So you could go ahead and define these different types of machine deployment types. I kind of showed you guys the worker, the logging, monitoring, routing, but you could also create machine deployments for special GPU. Say you want to run some type of AI or machine learning, you could spin these up, and you could use taints and tolerations to actually move the correct workloads to the correct node type or machine deployment type. You could also set special security, special anything. So you could define your machine deployment set. Some of the nice things about this is you could scale each deployment type independently. The desired state is managed by the cluster. You get auto scaling for free now. Also, if you do a configuration change, you'll get a rolling machine config updates throughout all those different node types. So now we have over-the-air updates. I kind of wanted to show you guys a new screen we have. It's the cluster setting. This is one of 2 areas where you could go ahead and update your cluster. You could either do it from our cloud.openshift.com, or you could do it from here. You could see all the available channels. So for example, if you have a dev environment and you want to set it to fast and nightly, we could go ahead and automatically update those clusters for you. But let's say this is a production system, you could set it to a manual approval process to upgrade your system, and you could wait for a production rollout is available. And then at that point, you guys could pick a good time for yourselves to update your cluster that way. Something else I want to show you guys on here is we now offer you the update history, so you have a history of how your cluster has been modified throughout time. The next tab over is the global configurations. So we've kind of surfaced all these configurations via the operator, and we're showing them here. You have everything from authentication, DNS, your image registry, infrastructure, ingress, OAuth. There's a screen with the OAuth there that shows you how to go ahead and modify the identity provider and add a new one there. This leads to the actual cluster operators. We're all in here. We've moved everything into an operator, and you'll see this is where you'll get the list of all those operators. You'll see the status of each. You'll see any messages coming back from the operator here, and you'll see what exactly the version is. So one of the cool things is, like, if you go to the update page, you'll see a live transition here of things getting updated. Say as the operators are getting rolled out, if an error happens, you can see which operator failed, it'll pause the rollout, and then it'll roll back to the previous version for you. So we definitely don't want to mess your cluster up, and we have safeguards in there for that. So as you see, every part of the stack is going to be right here. So these are all the operators that we currently use ourselves. Kind of to recap, for the day two operations, we use 3 different types of operators really. The machine operator to manage and grow your machines and add nodes to the system. The cluster operator, which is all the underlying kube and OpenShift services that we have. And then we also have the update operator that manages your upgrading of the cluster. So essentially those operators are the core of the system. We have something like Rob talked about earlier, is OPERATORHUB. We have 2 versions of OPERATORHUB. One's going to run locally in your cluster. One is the OPERATORHUB.io, which you could bring down services as well. The nice thing here is the admin gets to kind of pick and choose what operators are going to be visible to the users and developers on the system. And we have several types of operators here as the Red Hat products, ISV partners, and community. So this is where you could bring in more managed services into the system. Because of the operators, we now have an operator-powered UI extensions, right? So for example, one of the biggest complaints we had was OpenShift was bloated. So we've actually slimmed it down to the core components. Now, for example, if you want to support virtual machines, you could go ahead and get that CNV operator, enable it. That's KubeVirt. You'll now get a native experience. You'll see all your VMs right there next to your pods. Same with metering and chargeback. You'll get a native experience there as well. For monitoring, you have our Prometheus and Grafana dashboards. So what we did there was we actually took some of that experience, made it native, brought it in natively into OpenShift itself. And then if you want to do some more advanced stuff, we give you links back to the dashboard so you could go do further monitoring activities that you may need to do. We also have an external app launcher. So some products already have really great UI user experiences. For example, Service Mesh has Kiali. So if you come in and you enable Service Mesh, we'll give you an external link to jump into their user interface within context. So the last thing here I want to show you guys is the developer catalog. We've kind of combined everything we have, so now you're going to have a one-stop shop of operators, service catalogs, brokers, source to image. Think of this as almost kind of like your app store, right? So these are all the items available to your developers that they can access and take advantage of. So here's a visual of what I consider like the next generation of a enterprise Kubernetes, right? Starting from the bottom of the stack, you have the Red Hat operating system, then you have layered on as Kubernetes, and then you have the automated operations. That's essentially all the operator stuff we're adding, operator framework, the OLM, OPERATORHUB. We really added this layer of automation to take Kubernetes to the next level. And that gives you all these different types of services that go on top of it. For example, in the cluster services, you're going to get metrics, chargeback, registry logging. Some of these items are optional, and you can kind of like, again, pick and choose from OPERATORHUB what you want to bring into the cluster. You got application services, so all the Red Hat middleware is available, Service Mesh, functions, Knative, any applications that ISVs have to offer, you'll be able to pull those in as well. And then you're going to have the developer services that'll give you dev tools, pipeline, CI/CD, and IDE functionality there. So we've actually, I feel like the team's done an amazing job of getting OpenShift 4 where it is. We would love for you guys to come and try it out. If you go to try.openshift.com, you'll be able to get the developer preview and install this to AWS today. A couple items I wanted to tell you about that though. You probably don't want to do this on your production account. It is a developer preview. And then the second is you're going to need, your AWS account is going to need a decent amount of access. So make sure you'll have that because you'll be creating VPCs, load balancers, security groups, all that good stuff. Here's the command line that you're going to get from when you go to try.openshift.com. I wanted to share this with you because say before you want to create the cluster, you kind of want to see what it does. Here are a couple of commands that will show you all the configurations, and so you kind of look under the hood to see what's going to actually be deployed to your AWS account. But whenever you're ready, the command is just create cluster, and in about 20 minutes or less, you'll have a cluster. And if you want to ever clean it up, just run the destroy command, and that'll clean it up for you automatically as well. And that's all I have for you guys today. Thank you.